Okay, let's take a look at this one. Here it says that a car manufacturer wants to test an engine to determine if it meets new air pollution standards. So the mean emissions of all engines must be less than 20 parts per million. So we decided that we're going to test by building 10 engines and record the data on their emissions, right? And remember, our threshold, or our population mean, is going to have to be what? It's going to have to be less than 20 parts per million. So we're pretty confident that that's going to be our, oops, come on. That's going to be our mu. Our mu is 20 parts per million. So our mu is almost always going to be our hypothesis null statement, right? So here's our H. Oops. Me and this computer aren't getting along too well. So this is the null hypothesis, is that it's equal to 20. And since we want to be less than 20, our alternative, H of A, is going to be that it's going to be less than 20 parts per million, right? So, and we have no doubt we're going to have some sort of a threshold that we have to meet, right? And it says here that our alpha is 0.01. So once again, you know, I like to draw a little normalized curve over here, and so here's kind of what's happening here. Our mean for our population is 20, and of course we have no desire to be greater than 20, right? So we certainly don't want our test to end up over on the right side of that. We would love to be to the left of that, and in fact we'd love to be far enough away so that we are confident to this level, 0.01, that we meet that standard. So let's go ahead and draw that. And let's see here. So that standard might be somewhere over here. Hope you can see that. 0.01. And if our test result gives us an area that's in this section here, let's shade that yellow. If we're in this section over here, then we are going to reject the null that we are equal to 20. And we can then accept our alternative claim, which is that we are in fact less than 20. So we do not know anything about the population standard deviation. So we have no way to come up with that sigma, right? Now, we can come up with the standard deviation of our sample, right? But the calculator is going to do this for us, right? So we're going to take advantage of the fact that we're going to put our 10 engine data points into list number 1, and then we're going to run our t-test, right? Because the t-test is used when you know the population mean, and we do know the population mean, right? It's right here. Population mean is 20 parts per million. That's the standard that we have to get to, or less than. And we do not know the population standard deviation, and we could find the sample standard deviation, right? But the calculator will do that for us if we use our t-test. So we're going to go to we're going to enter these in, and we're going to run a t-test on one sample, because we have one set of data. We're not comparing two separate engines or anything like that. So let's just go ahead and do it real quick. And I've already typed these in just to save a little bit of time. Let's double check and make sure it's still there. So we'll go to Edit, Stat, Edit, and you'll see that I have those 10 data points already created in there for you. So if you want to follow along, you can pause the video. Okay, I hope you have them in by now. I'm going to go ahead and quit out of this, and I'm going to go to Stat, to our test, and I'm going to take a look at our t-test, which is test number 2. And we're going to go over and make sure that we select list 1, type in that 20 is our null hypothesis, or our population mean, and since we are interested in getting less than 20 parts per million, because that's the only acceptable answer we can get, and we're going to hit calculate, and we're going to see that our probability is equal to 0.007. And the only thing that we need, let's see if I can capture that, there we go. So all we need to do is to ensure that, sorry about that, we just need to ensure that we are below that threshold, right? And since we are at 0.007, and the next line tells us exactly what our population mean is, right? For our sample, we got 17.17. So we're quite a bit below that 20 threshold, and using this t-value of -3, the calculator automatically gives us that probability that I've highlighted in green right here, of 0.007. So how do we write this up statistically so we can get credit for this on a test or something? We say that our probability is less than our alpha of 0.01. Okay, because that's true, and let me just write it out explicitly. Man. So in other words, our probability is 0.007, and that is certainly less than this test point that we've given ourselves of 0.01. So since this is a true statement right here, we are going to reject the null, and if we reject the null, so we reject the null, reject the null, and that's always true, regardless of what test we're doing. If we're doing a hypothesis test, if our probability is less than our threshold, we're going to reject the null, reject the null. Thus, we're going to accept our claim that our engines are less. Wow, this is just crazy. We're going to accept the claim, and I'll try this one more time. Accept the claim that our engines are less than 20. Okay, I hope you found this video helpful.